In this video, we will explore some trigonometric thought questions. Back in the 90s, there was a man named Arsenio Hall, and he had a segment on his night show that he called Things That Make You Go, And this could have been on that show. Alright, for example, number 6. Explain why the cosecant of pi is undefined. Well, I like to draw lots of pictures. Not because I'm good at it, obviously. If this is the unit circle, then here's pi over here. And the coordinates of the points, a little tongue-tied there, the coordinates of the points as you go around have significance. You know how this point, for example, is 1, 0, this is 0, 1, and this one would be -1, 0, and 0, -1. Now, cosecant. What do we know about cosecant? Well, we know that cosecant is the reciprocal of the sine function. So cosecant of pi is the same thing as 1 over sine of pi. So, what is the sine of pi? Well, every coordinate on the unit circle is cosine, sine. So sine is the y value. So looking at pi, wow, there's a large highlighter. Looking at pi, sine is the y. Shapow. And as you can see there with my giant single-click highlighting, 0. The sine at pi is 0. So that makes this thing, it makes it 1 over 0, and of course that is undefined. So that is why, but we need to explain. So we need to take these symbols and put some words behind them. So organizing our thoughts here, we could say something like this over here in gray. Cosecant of pi is equal to 1 over the sine of pi. Since sine of pi is 0, the cosecant of pi equals 1 over 0, which is undefined. That's why the cosecant of pi is undefined. Alright. Let's look at the next one. If sine of theta equals cosine of theta, in which quadrants, or what quadrant, may theta lie? Alright, so are there any quadrants where the sine and cosine could be the same thing? Alright, just think in terms of a triangle for a second. Alright, if this is theta, from the perspective of theta, you've got opposite, you've got adjacent, and you've got the hypotenuse, right? To make it easier, I'm going to call the opposite y and the adjacent x and the hypotenuse h. Now, we know that the sine of theta is opposite over hypotenuse, so that would be y over h. The cosine of theta is adjacent over hypotenuse, so that would be x over h. So the question is there an angle where the sine of theta will equal the cosine of theta? That would mean that y over h would equal x over h. Well, since they're both over h, the only way that would happen is if y and x were the same thing. So is there any angle where where the y and the x are the same? Well, if these were the same, that would make this isosceles, wouldn't it? And if this is isosceles, what angle is that? 45 degrees. And then now that you think about it, I said, now that you think about it, don't we know that the sine of, I can't think straight. Don't we know that the sine of 45 degrees is 1 over radical 2? And the sine and the cosine of 45 degrees is also 1 over radical 2. Some call this radical 2 over 2. So 45 degrees. That's the angle where the sine and cosine are the same. So that's definitely one angle. Now if you want to talk quadrants, we can talk quadrants. So we've established that in the first quadrant here, at pi over 4, or 45 degrees, sine and cosine are the same because they are both 1 over radical 2. Okay, so we've got quadrant 1 on board. What about quadrant 2? Well, if I use that same reference angle, I'm going to get 1 over radical 2 for the cosine and for the sine, except for one thing, the positive and negative. Cosine is negative in this quadrant because it's the x value. It's going to be to the left, so that's negative. On the other hand, the sine value is positive. So that's real close in the sense that they both have 1 over radical 2 for the sine and cosine, but hey, one's negative, one's positive. That is not the same. So that's a fail. Now how about the third quadrant? Well, in this quadrant, again, if you use the reference angle of pi over 4, once again you're going to get the 1 over radical 2, 1 over radical 2 for the cosine and the sine. Now if you look at the positive and negative, both the sine and the cosine are negative in the third quadrant. And that's great if you're trying for them to both be the same. So there you go, they are both the same in the third quadrant. So that means the third quadrant is on board. 1, 2, 3. So we've got these two quadrants. I think you get it now. This quadrant is going to be a fail. Once again, we can do 1 over radical 2 and 1 over radical 2 for the cosine and the sine. But when you look at the positive and negative of it, the cosine is positive in the fourth quadrant because it's to the right. It's the x value. But the sine is negative in this quadrant because it's down low. It's a y value. So they are not the same. So that's a fail for the fourth quadrant. So the only quadrants where you can have the sine and cosine be the same number is at pi over 4 reference angle, and that's going to be the in the first quadrant and in the third quadrant. So as you can see, that is option D. First and third. Okay, number 8. If cosine is greater than 0, in other words, if cosine is positive, then which of the following must be true? Alright, I think I'll need to draw my picture right here where I can keep an eye on it. I'd rather have a nice big picture, but this will have to do. So here's a picture of a circle, maybe a unit circle, just so we can visualize the quadrants. So we're given that the cosine is greater than 0, all right? The cosine is positive. So that means we are dealing with x values, right? We understand that the cosine is the x value. So positive x values happen on the right hand side. So this area over here, quadrants 1 and 4, this is where cosine is greater than 0. This is where cosine is positive. So which of the following must be true? Does the sine function have to be positive? No. The sine function is the y value, and it's positive up here, but it's negative down here. So no, just from this highlighting, that does not mean the sine function has to be greater than 0. So that's a fail. How about the secant function? Does that have to be greater than 0? Does that have to be positive? Well, the secant function is just the reciprocal of the cosine function. So yeah, this, if cosine is positive, then the reciprocal of cosine will be positive. So this must be true. Okay, just to follow through, does the tangent have to be positive? No, tangent is positive in this quadrant because you have the sine and cosine are both positive. But so I'll say that means tangent is positive. This is cosine, sine, tangent. But in this quadrant down here, the fourth quadrant, cosine is positive, sine is negative. I don't know what that random mark right there was. Try again, Burton. This would lead to a negative tangent. So no, tangent doesn't have to be positive. And cosecant, does that have to be positive? No, because cosecant is just the reciprocal of the sine function. And we already determined that the sine function can be positive up here but negative down here. So the answer is B. Okay, one more thought-provoking trig question. Determine the quadrant in which theta lies if secant theta is less than 0 and tangent theta is greater than 0. Alright, well, it's almost like the last question. Let's draw our schematic. Okay, well, secant goes right along with the cosine function, because secant is just, let me change colors. Secant here is just 1 over the cosine function. So these are positive together and negative together. So when I talk about secant being less than 0, that means negative. That's going to happen wherever cosine is negative, because taking the reciprocal doesn't change the sign. So this is saying that the cosine will be negative. The cosine is the x value, and we know that x values are negative, ghostwriter, on the left-hand side of the picture. Alright, to the left of the y-axis, that's where x values, and thus the cosine, and thus the secant are all negative over here. Okay, so there's that. But then they also say that tangent is greater than 0. Okay, so let me just add in some stuff. So they're saying that cosine and this business was negative, right? But now they're saying tangent is greater than 0. So that means tangent is positive. Do you get that? So where is tangent positive? Well, tangent is positive in 2 quadrants. Tangent is positive here, and tangent is positive here. The reason why is because sine and cosine. Cosine is positive in this quadrant, cosine is positive, and sine is positive. Tangent is sine over cosine. Positive divided by a positive is a positive. In this quadrant, cosine is negative and sine is negative. A negative divided by a negative is a positive. So in the other quadrants, we have a positive cosine and a negative sign. Alright, those are different. So that's tangent's going to be negative right here. Negative divided by a positive is negative. And in the second quadrant, cosine is negative, left. Sine is positive, up. So since they're different, the tangent will be negative. A positive divided by a negative is a negative. So, again, to repeat, in which quadrants are the tangent, or is, are, where is the tangent function positive? This these ones where I put a plus sign, but let's go ahead and highlight that up to be more, like dramatic or something. Okay, so tangent is positive here and here. Okay, now because of my clever use of coloring, we want the tangent that was highlighted twice. I'm sorry, we want the quadrant that was highlighted twice. And because of the clever mixing of yellow and blue, you should be looking for the quadrant that is now green. So as you can see, it is the third quadrant. Alright, that's the quadrant where the secant is negative, alright, and the tangent is positive. So that's the only quadrant where that happens. So quadrant 3 is the answer. Ta-da! Alright, and that is the end of our trig questions that make you go, thought-provoking. Here endeth the lesson.